Hi, welcome back. Our previous lesson was on the part 2 of deriving the Marshallian, Hicksian, and Slutsky demand curves. Today we'll be moving on to the part 3, focusing on the Slutsky demand curve. We mentioned that the Hicksian demand curve illustrates the movement along a given indifference curve for alternative prices, and the Slutsky demand curve in this case it represents how a consumer will respond to a change in the price of good when they are compensated enough to enable them to afford the same bundle of goods before the price change. So the aim here is to keep the consumer on the same purchasing power. Now let's move on to a graphical representation of the Slutsky demand curve. So before we draw our Slutsky demand curve, let's record that our Marshallian demand curve represented as dm was derived by connecting point A and point B, and we mentioned that this incorporates both substitution and income effect. So we see this as a change in demand from x1 to x2, where this is total effect, and the difference here is substitution effect, and the difference here is income effect. So the Marshallian demand curve exhibits both the substitution and income effect. Then our Hicksian demand curve is DH, and this is drawn by connecting point A and point C. And we see that this is purely the substitution effects from the price change, where demand change from X1 to XH representing only the substitution effect. And on the top part of our diagram, the Hicksian demand represents a change from E1 to EH, which we have mentioned is the substitution effect of a price change. To construct the Slutsky demand curve, we will start from budget line B1 and the equilibrium point E1 on indifference curve U1. The original bundle E1 contains X1 unit of good X. We assume the price of X increased from P1 to P2. This moves us to a lower equilibrium point E2 on budget line B2 and indifference curve U2. So to find the Slutsky demand curve, we have to give the consumer enough income so that they can afford their original bundle E1 despite the price change. So this is also the substitution effect, but it is using the Slutsky's method. We do this by drawing an imaginary line that is parallel to the new budget line B2. So we compensate the consumer with enough income, it moves them to this green line, and if it's not enough for them to afford the same bundle, we compensate them with even more income and compensate them with even more income until we arrive on the budget line that cuts across the original bundle E1. This imaginary budget line represents the compensation for the price change. The consumer will be compensated until they have enough income to afford the original bundle E1 despite the price change. This is represented as budget constraint BS. Given this budget, the consumer will choose the highest indifference curve that will maximize their utility. The new point of tangency is ES, which is on budget line BS, and a new indifference curve US. So this new equilibrium tells us the demand for good X when the consumer has been compensated enough so that they can still afford the original bundle E1 even though relative prices have changed. Now note that the fact that we say the consumer can afford the original bundle E1 doesn't mean that's the bundle that the consumer will choose. So we see that given the budget line BS, even though the consumer can afford the original bundle E1 because it is on the budget line, the consumer will not choose that bundle because there is another bundle ES lying on the same budget line but gives the consumer a higher utility. So it lies on a higher indifference curve US. So the level of demand associated with this new equilibrium point ES is X star. So if we trace this EX down, we have X star. Now, this represents the pure substitution effect of the increase in the price of good X using the Slutsky method. So this is called the Slutsky demand for good X, and we will label it as X star. Now, we derive the Slutsky demand curve by projecting this S star down to our demand graph. So we notice that this is the compensated demand for X when the price is P2. So at price P1, the demand was X1 at point A. And at price P2, demand reduced to X star using the Slutsky method. So this, if we trace it up, gives us point D. If we connect point A and point D, we obtain the Slutsky demand curve. We can label this as DS. We notice that the Slutsky demand curve, just like the Hicksian demand curve, is steeper than the Marshallian demand curve. And we mentioned that this is especially the case when a good is a normal good. And we'll be talking more about this in our next few lessons. So this is all that we have on the third part of our lesson on deriving the Marshallian, Hicksian, and Slutsky demand curves. Our next lesson will be on the fourth part, where we will be comparing the Marshallian, Hicksian, and the Slutsky demand curves. If you enjoyed today's lesson, consider subscribing. Thank you.